Okay, let's dive right into this explainer. Welcome to the Legal Brief, your ultimate computer science Cambridge exam strategy session. Today, we are cracking the code on mastering truth tables from logic expressions. But we're not just reading textbooks today, oh no. We are going to build your exam case like a top barrister. Think about it. To get that top grade, you need airtight evidence, a structured argument, and an undeniable conclusion that forces the examiner to award you maximum marks. Whether you are tackling syllabus 0417, 0478, 0983, 0984, 2210, or especially the advanced 9618, this strategy applies. Picture two students sitting in the exam hall right now. Let's call them Alex and Sam. Alex is the overloader. Alex memorizes every single raw computer science fact but provides zero actual analysis. Sam, on the other hand, is the rusher. Sam races through the paper, completely missing the specific requirements of the command words. Both of them are going to drop massive marks, and today we're going to examine their exact mistakes, transform their flawed answers, and show you exactly what the examiners are desperately looking for to turn a standard B grade into a definitive A star. Let's get started.
Here is our roadmap, or rather, the case docket for today. 1. The Truth Table Challenge. 2. Core Theoretical Principles. 3. The Procedural Framework. 4. Top Examiner Warnings. And 5. Final Exam Strategy.
Section 1. The Truth Table Challenge. Let's really look at why students drop marks. Remember our two candidates, Alex and Sam? When faced with a complex logic expression, Alex will write out paragraphs of theoretical fluff about what an AND gate or an OR gate is, overloading the page but completely failing to apply it to the specific truth table requested. Sam just calculates everything in his head, scribbles down the final column of ones and zeros, and moves on. Both get heavily penalized. Why? Because the biggest challenge in Cambridge computer science isn't just arriving at the correct final answer, it is prioritizing the analytical process over that final answer. It's the massive gap between what you think you need to do, just solving the problem, versus what the examiners are literally mandated to grade on their rubrics.
This brings us to a direct quote that you need to internalize. The assessment framework prioritizes analytical depth over superficial breadth. This is absolutely crucial, guys. The examiners are explicitly telling you that knowing a tiny bit about 100 different concepts won't save you here. You need deep, logical, structured reasoning. The person marking your paper isn't just running a scanner over your final truth table to see if the outputs match. They are evaluating your entire cognitive process. They want to see your brain working on the page. If you just give them superficial breadth, like Alex dumping definitions, they have no proof of your analytical depth. They need the evidence.
Moving to Section 2, Core Theoretical Principles. This is where we start building the foundation of your legal case for those top marks.
Cambridge expects you to demonstrate something called connected understanding. What does that actually mean? It means demonstrating mastery of fundamental principles by transferring them to completely unfamiliar contexts. In the exam, they are going to throw a bizarre, real-world scenario at you. Maybe it's a logic circuit for an automated greenhouse or an airplane landing gear system. If you just try to memorize past paper questions, you'll freeze. Connected understanding is your ability to take the rigid rules of Boolean logic and truth tables and seamlessly weave them into whatever wild context they've invented. You have to integrate precise definitions and establish causal relationships. If input A is false, it causes gate B to output false, which triggers system C. That is how you build a solid argument.
This concept brilliantly illustrates why some candidates get stuck at a C while others soar. Let's compare superficial breadth versus analytical depth. Superficial breadth is Alex writing, an OR gate outputs 1 if either input is 1. Sure, it's true, but it's shallow. Analytical depth is structuring your answer using the Peel framework. Point, evidence, explanation, link. Top students use Peel to break down command words. Your point identifies the logic state. Your evidence points to the specific inputs given in the scenario. Your explanation details how the logic gate processes those inputs. And your link connects it right back to the overall system output. We are going to put this into practice shortly. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right. Section 3, the Procedural Framework. How to actually construct your answer. This is the exact sequence, the success blueprint you must follow when tackling these examination questions. If you want to achieve top-tier algorithmic thinking, you must systematically execute these 5 steps. Step 1. Deconstruct the question. Underline the command words. Are they asking you to evaluate, describe, or construct?
Step 2. Extract the relevant data. Pull out the exact number of inputs and the specific logic expressions. Step 3. Select your analytical framework. This is where you might apply our Peel method to structure a written response. Step 4. Execute with clear notation. Don't use messy scribbles, use standard Cambridge logic notation. And Step 5. Present with correct terminology. Call it a Boolean expression, not just a math formula. If you skip even one of these steps, you are leaving easy marks on the table.
This procedural application is exactly what develops your core programming skills. Algorithmic thinking in practice requires step-by-step decomposition, appropriate data structure selection, efficient code implementation, and rigorous testing. In the context of a truth table, algorithmic thinking means you don't just guess the final column. You break the complex logic expression down into its smallest parts. You test it rigorously by calculating the intermediate columns first. It forces you to design, implement, test, and evaluate your solutions like a professional computer scientist building a case.
Now we hit Section 4, Top Examiner Warnings, the Danger Zones. This is where the red pen marks transform into green check marks. Let's look at the insider secrets directly from the principal examiner reports on why students lose marks.
We're counting down the top 3 mistakes. Mistake number 3, providing answers that are not specific to the context given in the question. Remember Alex? Alex will write an entire page explaining how logic gates work in theory, but completely ignore that the question asked about a security alarm system. The examiner's verdict? 0 marks for context. You must anchor every single piece of logic back to the specific scenario provided. If the input represents a motion sensor, call it a motion sensor in your written explanations, not just input A. Stop scrolling! Subscribe to our YouTube channel ACE Exams at ACEXams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to ACEXams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Mistake number 2, forgetting to check your boundary conditions and edge cases. Let's do a quick interactive workshop right now. I'm putting 60 seconds on the mental clock. Imagine scanning a complex data table of logic expressions. What is the core trend you need to extract? It's the extremes. What happens when all inputs are true? What happens when all inputs are false? These are your boundary conditions. If you don't rigorously test these edges, your entire truth table is vulnerable to hidden logical errors. Examiners purposely design questions where the middle rows look totally normal, but the trick is hidden in the very first or very last row of the table. You have to check the boundaries.
And the absolute number 1 mistake is failing to check for overflow and edge cases when constructing your truth tables. Students get so tunnel-visioned, just like Sam rushing through the paper, that they toss away incredibly easy marks. Let's do another quick challenge. Find the flaw in this thought process. I've solved the first 3 gates, so I'll just assume the pattern continues for the last gate. Boom, that's the flaw. In computer science, assuming a pattern without executing the logic is a death sentence for your grade. Complex logic expressions usually hinge on those specific weird edge cases. This is exactly where the examiners separate the A-star candidates from the B-grade candidates.
Please, if you take nothing else away from this session, burn this rule into your memory. Examiner alert. Show you're working. This is your ultimate defense in the exam room. Even if your final binary output is entirely wrong, let's say you accidentally flipped a 0 to a 1 in the absolute final step, showing your step-by-step intermediate logic columns allows examiners to award you critical method marks. These method marks can literally save your grade. Never, ever just write down the final column like Sam does. Prove your process. Let's do a 30-second speed writing mental check. If you have to write a Peel paragraph for this, your evidence is those intermediate columns. No working means no evidence, which means no marks.
Section 5. Final Exam Strategy. Evaluation and Execution. Now that we know the pitfalls, how do we guarantee execution on exam day? It comes down to a time management matrix and a solid problem-solving loop.
This is the ultimate deconstruct, solve, evaluate loop for complex logical expressions. 1. Identify given info. 2. Break into logical steps. 3. Solve systematically. 4. Check reasonableness. 5. Make justified recommendations. Think about step 4, check reasonableness. If your final truth table outputs a scenario that logically contradicts the core premise of the question, like the airplane landing gear deploying while cruising at 30,000 feet, that is your massive red flashing light to go back and check your logic.
Sometimes the command word will ask you to compare different logical approaches. If you are asked to critically analyze, make sure you hit every single one of these points on the comparative analysis checklist. Identify similarities and differences. Don't just list one side of the argument. Use clear comparative connectives like whereas, however, or conversely. Support each comparison with direct evidence from your truth table. Referencing specific row numbers is a great trick here. And finally, draw clear conclusions on their relative importance. This is how you deliver a verdict the examiner can't argue with.
To lock all of this execution strategy in, try creating your own mnemonic using the first letters of key terms. For our procedural framework, think DESEP. Deconstruct, extract, select, execute, and present. DESEP. Having a mental cheat sheet like this ensures that when the exam pressure hits, the clock is ticking down, and you start feeling panicked like Sam, you don't skip a crucial procedural step. You just breathe, trust your training, and follow your algorithm.
As we close the case on today's explainer, I want to leave you with one final provocative question. When you sit down to practice your next pass paper, ask yourself, are you prioritizing the final answer or the logical process? Because in Cambridge Computer Science, proving exactly how you got there is the true, undeniable secret to exam mastery. Don't just show them what you know, show them how you think. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.